knowing what these different assets are, knowing the difference between a scene, a texture, a mesh, a material. Because I remember when I was first learning Unity, I would sometimes get these mixed up, but you don't want to get them mixed up, and want to know what the difference is. A mesh is like a 3D model that you build in an application like Blender or 3D Studio Max. On top of the mesh goes a material, and then that material can contain a number of textures and shaders. And textures are basically just, if you unwrap them, they're basically just like an image. Script is a code-based thing. Right now, Unity only supports C#. They used to have their own kind of JavaScript language called Unity Script, but they dropped support for that, I think, in Unity 2018, maybe 2019, but yeah, it's gone now. Prefabs are game objects that have been turned into cookie cutters. Sounds are sounds. And scriptable objects are game objects that hold configuration for your project. You have the UI canvas, which is used to create the heads-up display. It has its own camera. There are ways of getting the camera to interact with your 3D objects or the things in your actual scene. That has to do with the different layers. And then event triggers are the properties that exist on your UI properties and elements that tie them to the scripts on the back end so that your objects on your GUI have functionality. Components are transforms, cameras, lights, particle systems, colliders, rigid bodies, and mesh renderers. Anything that you can put onto a game object that inherits from mono behavior. Game objects, you want to understand the concepts of parents and children and how those affect one another, and how you get components from a parent or a child. Understand that if you are a child of something and something happens to your parent, if it gets transformed or rotated, then that will affect all of the children in that same way. Lights, there's 3 or 4 different types of primary lights that you use in Unity. Point light or a directional light. There's light baking, which is a more advanced graphics function that Unity has that I don't believe we'll get to this course. There's particle systems, which we went over. Basically, if you want to create smoke or flying hearts or explosions, that's really how you create those things. Colliders. Colliders are used for detecting whether 2 objects are running into each other. Collider is usually resembles the shape of the mesh. I advise against using the mesh colliders. They are computationally expensive and will slow down your game. You don't really get that much benefit to putting a collider on every single surface of a object. Usually, as long as you put a capsule or a sphere or a box collider around your object, you get essentially the same functionality for a lot less computation. Rigid body has to do with the physics of an object. This is what gives things gravity. This is what gets things to also collide. You need a rigid body in order to have colliders working. And then mesh renderers, which is the component that renders the object so that you can actually see it. Yeah, the prefab editor will go more into, we didn't get too far into that, but it's a very powerful tool that was introduced quite recently into Unity. Tagging, we talked a little bit about. Instantiation of prefabs, we did that last class period. Destroying game objects, we did that last class period. And then scripting, I put probably the 10 or 12 most common things that you'll do with scripting in Unity. Understanding mono behavior, how to turn something into a component that can be dropped on a game object. That's probably the most important thing. We're going to kind of retest for that right after this. I want to make sure that everybody knows how to make components and put them onto game objects. Coroutines, which are used to handle multi-threading. The scene manager, which is used to flip back and forth between different scenes. We haven't used this functionality yet, but it is important if you make a game with more than one scene. The scene manager handles all that and is actually pretty straightforward. It's not real complex, but yeah, it's important to know how to use it. Components, which are all of these things up here that we already talked about. They go on game objects. Properties, which are parts of the component. A component can have multiple properties. Time, we won't mess with too much, but there are actually functions within Unity that allow you to adjust time. So if you want to slow down your scene to give it like a slow motion effect, you can actually do that very easily in Unity. That's pretty cool. The different force functions, the execution order. We already talked about putting things in awake versus start, but sometimes you want one particular script's awake to execute before another script's awake. And so you can actually do that by coming into your project settings, and then in the script execution order, this is where you can drag and add new scripts so that they execute in the order in which you'd like them to execute. They're all given 0 by default. This information is actually kept in the metadata file that Unity creates for every single file in your project. If we were to go to our project, you'd see a meta file for every single folder, and you'd see a meta file for every single script. The meta file is where this script execution order information is kept. Vectors, quaternions, lerps, those are all used to transform game object positions and rotations and sizes. We'll go more into those, I think, over the next week or so. We did do some vector things last week. Lerps are interesting because you can use a function to change your values, which is usually a useful thing. If you don't want it to behave in a linear function, you can lerp it and do it in either an exponential or some kind of quadratic order. Inputs, if you're going to be getting inputs from the screen or from the mouse, those are important. Raycasting is, again, another more intermediary to difficult scripting. We won't get into raycasting too much. Just know that if you want to pick up things, like what's in front of your camera or what's in front of your gun, you use a raycast. And of course, debugging, we went over, showed you guys how to use the debugger. I did find a book that people can order online. It's a good reference material where I thought I had posted that. I might have just sent it to Aaron, and yeah, I don't know if it actually got posted. I will send you guys the link to the book on Amazon that I found. Yes, there was a few people in class that were wanting to have a reference material, a book to follow along with. And so, yeah, I found a pretty decent one that a lot of the stuff that they cover in the book we've actually covered already in class, which is good because we're kind of at the halfway point now. And yeah, hopefully you guys are having a familiarity with how to navigate around in the editor, you know, the primary functions and things that I've listed here are also in that book. And so, yeah, I wanted to kind of start off and have everybody on their own create a new project. And inside of our sample scene, we want to have a plane and we want to have a box. And whenever you push the space bar, that box will jump and then come back down onto the surface that you create. So why don't you guys go ahead and take 5 to 10 minutes and create a surface and a box that can jump on the surface. And when we come back in 5 or 10 minutes, we can make sure that everybody was able to do that. The only script that you'll have to write is 2 lines of code, 2 or 3 lines of code where you input the enter button or whatever button you want as your jump button, and then you add a force to your box, or you can manipulate the transform, or you can use the I wouldn't use the animator. We didn't go over the animator very much, but if you've gone through a lot of the tutorials and things on your own, then you might know how to also do it with the animator. But go ahead and everybody create a surface and a box that jumps on the surface. Or does anyone not know how to do that? Is anyone completely stuck and just doesn't know where to begin to start doing that? Please let me know, and I can give you some additional pointers or suggestions in the chat. But yeah, right now we just want a surface and a box that jumps on the surface. Okay, let's just do a quick check. Adam, how are you doing on this? Are you, did you get through everything? Were you able to get the box and the plane and make the box jump? Unity just crashed. Well, all right, we'll wait. Taylor, were you able to get the box to jump?
I have the cube in the box. I didn't do the scripting part.
Okay, good. That's a start. Does the box fall? You added the rigid body to the cube so that it falls on top of the surface. So anything that has a rigid body will then have gravity, and if you don't have a rigid body, then you're not affected by gravity. And then, yeah, the script, we'll go through the script together. It's more or less just 2 lines, but it's kind of tricky because you have to use a vector 3. And yeah, we'll go into vector 3Ds a little more once everybody gets their box and the surface. So make sure that when you add a cube, you can stretch its scale. You can either have 2 cubes or you can have a quad. A quad is basically an ultra thin surface. It still has a surface thickness of 1 here. But you do want to rotate it by 90 degrees because it comes in by default like this. And so you want to just rotate it by 90 degrees in either the X or the Z direction. Or no, not Z. X, just X. And then after you've done that, you want to make sure that your cube is above the plane, because if it starts off and it's in the middle of the plane, because whenever you add something, a default position is 0, 0, 0, so you want to bring it a little bit above, and you can do that by either using the handles here. If you've got this move tool selected, you can select the move tool with W as the hotkey. Otherwise, you can just come over to your inspector and you can adjust it like so by dragging the handle on the Y property of the position transform. You can start it way up here, push play, and watch your box fall as it starts. Otherwise, you can put it right on the surface. But what you don't want to do is have it kind of halfway through the surface, because then the collider gets confused, and I'm pretty sure it will just drop right through the bottom of the plane. So yeah, make sure that your cube is slightly above. You'll be able to see the shadow because of the directional light. If you were to get rid of the directional light, you can't really see too much of anything. You almost need a light in your scene. You can still kind of see the silhouette because we have a backdrop. We've got a skybox that kind of lets you know that it's there, but you almost always need some kind of light source from somewhere. It doesn't necessarily have to be a directional light. If we wanted to turn this into a point light, we could do that as well. Point lights look kind of funky. We definitely want the range to be bigger. Directional lights definitely add the most light to a scene. But yeah, that's the light. Let's set it back to directional like it was by default. The main thing I want to get is that you guys are able to create these objects and kind of manipulate them around in the scene. Chris, did you guys manage to get your box and surface and get the jump script created? We'll go through the jump script together, but I just want to make sure that everyone's got these two new game objects. Make sure that we're getting the terminology right inside of the hierarchy. All of these things are called game objects. Whenever you click on a game object, over in the inspector, it shows you all of the components of the game object. And if you want to create new components, such as a jump script, you do that by right-clicking over here in the project window. Okay, so it seems like everybody's got these game objects in their scene, which is good. It's time to go over to the script. Make sure that you've created a jump script. You can right-click and do create C# script if you want to create it over here in the project. Otherwise, you can come right over to your cube and do add component. And if you do new script, you can do the same thing here where called it jump 2. And I did create an add, it would automatically open up my Visual Studio, but it added that jump 2 script to my cube, and then over here in my project, it also added the jump 2 script to the root level assets folder. Yeah, I don't really need 2 jump scripts, so I'm going to go ahead and delete this one. Notice that when I delete it, it warns me, hey, you can't undo this. Unless you've got it in your versioning control, you are about to destroy something. And then over here on my cube, where I had that jump 2 script, it says missing because we just got rid of the jump script. So we are going to want to remove that.
How do you change your view so you're looking at your pane from above? I'm looking at from the side.
You mean the scene?
Yeah.
The scene view, you can use Alt and you can orbit around. Oops.
Oh, I was in the game view. That's why it's so hard.
Yep, game view doesn't allow you to maneuver around or anything. That is just what you see when you hit the game camera. Yeah, the scene is really where you want to be. And this allows you to orbit or to focus on different components in your scene. Yeah. I usually try and use 2 monitors because it just makes life easier. I keep my project and scene in different windows just to, keep it straight. Normally you'll quickly realize that you're not in your scene. The scene has got gizmos, and the deadest giveaway is this navigation thing right here, because this is how you do the snapping. If you want to go and see, top down, you can do top down. You can maneuver around, orbit. Once you've been using Unity for a couple weeks, you get pretty good at maneuvering around in the scene. As long as you have a mouse. This is hard to do with a trackpad, I've found. So let's go to our script. Make sure everyone's got a jump script. It doesn't necessarily have to be called jump, but something, jump is descriptive enough for this purpose. And you can either, in order to get to the jump script, you can do the ... There's edit script here. You can click on this, which highlights this, and you can double click this, or you can even just double click this. There's a lot of different ways to get your Visual Studio to open up in your script. By default, all script files that inherit from mono behavior are given a start and an update. for our purpose, we want something in update because we're going to be checking every single frame. Hey, are we pressing the space key? So the first line, our first line of code here, basically says, are we pressing the space key? This is input get key. There's also input get key down. The difference is one's only going to fire once, and the other one fires every single frame you've got that key down. And so get key down is the one that only fires during the frame that the user actually pushes the button. If you want it to be a machine gun, then you use get key. So if the space bar is pressed, then we do whatever it is we're going to be doing. Make sure that if your cube doesn't have a rigid body, that you add a rigid body component to it. Otherwise, none of the force functions are going to work. And the force function is really probably the easiest way to make something jump in 3D. Yeah, I wrote both ways of doing it. If you wanted to transform, if you do it this way with the transform manipulation, you don't actually need rigid body. So what we're doing is we're taking the position of our cube, or whatever game object our jump component is on, and we are translating it in the a particular direction, and all directions are vector 3s. This is the X direction. This is the Y direction, which is the direction that we want to go. We want to go up. We want to jump. And so we're transforming just by a little bit because our box isn't very big, right? Our box is only one, only has a scale of 1. And so every frame you have the space down, it's going to be adding that. We could change it to get key down, and it'd be a little more controllable. That might actually be a better solution, get key down, and that way we can add a little bit more force, or a little bit more here where we're going up by a distance of 1.5. And this will work. It won't
what about
be
the vector up? I think it just represents 0, 1, 0.
Yeah. So you could also do vector dot up, vector 3 dot up. This is equivalent to 0, 1, 0. You could also then multiply it by 1.5f. If we've got any mathematicians or vector calc people out there, when you do this math, it will come out to 0, 1.50 when you do the multiplication. So this is also essentially the same thing. Let's go over to our Unity editor and give it a test here. Boop, boop. Notice how it's not smooth. That's because whenever we hit the space, it immediately transfers it to 1.5 f. If we wanted to do that a little more smoothly, we would lerp it over time. The other way to do it a little more smoothly is to add a force. Instead of doing the transform.translate, in order to get the force function to work, we need a rigid body. We want a rigid body anyhow, otherwise the gravity wouldn't work. But what happens is we're getting the rigid body component that is on the same game object as our jump component, and we're adding a tiny bit of upward force to that rigid body. So there is another way of writing it. We don't have to write it like this. We could do just like we did before if we wanted to do vector 3 dot up. And this might even be a more intuitive way of doing it anyhow, by a force of, let's do 50. I think before we had 20, but that was running every frame. So this will, this should be appropriate. And this is something that you can adjust. Looks like 50 barely gets us off the surface. Let's add a little bit more force. There's different types of force too. The teletext will let you know. So rigid body has a number of different forces. There's explosive force. Explosive force sounds a bit more like what we want. Unfortunately, explosive force wants a little bit more information. It wants actually a lot more information. Yes, let's just stick with force by just regular force for now. Explosive force seems like it adds force in a bunch of different directions. It'd be good for an explosion, but not necessarily for jumping. You can also add torque. If you're a wheel, you can add relative torque. What other kinds of force do we have? Add force at a particular position. Add a relative force. Add force is probably the most intuitive or straightforward. And adding force, getting into the physics engine can be pretty tricky. Yeah, you want to have a math background if you're going to be messing around with force a lot. It's usually just easier to manipulate the transform or use the animator. But I want to show you guys kind of all of the options. Let's jack this up to 250 and see if it works better. I think it should work quite a bit better. Barely got off the ground before. Now, yeah, that's an appropriate jump. We don't actually have anything that prevents double jumping, so we could basically make our box jump and float in the air if we wanted it to. Yeah, that's our jumping box. I want to stop and make sure that everybody understands, are there questions on this? I want to make sure we didn't go too fast. Everyone's got their box jumping and understands how and why their box jumps. Our script wasn't too complex. It was really just a few lines of code. And that's kind of the beauty of Unity is you can do a lot with just a few lines of code.
Yeah, force is kind of like a rocket ship because you can still catch as you're falling.
Yep. If we wanted to prevent the player from double jumping again, we would have to add some kind of property called isGrounded, where we're checking to see if we're actually on the ground. Yeah, that might actually be a good second task. Let's go ahead and add a variable called isGrounded to our jump script. And the other function, the two functions that we're going to be using to set our isGrounded is on collision. If you guys recall, we did on collision stuff last week or maybe even the week before, but it's one of the built-in Unity functions for mono behavior. And yeah, if you want to see all the different functions of mono behavior, teletext gives it to you. Otherwise, you can push F12 in your editor and it will go to the mono behavior script, and you can see all of the different functions that mono behavior has. It looks like it inherits from behavior, and behavior's got all of these, actually not even that much. Component is probably the magic. Yeah, this is where all components might have lights or renders or rigid bodies or cameras, or a tag. But they have colliders, so they also have this on collision on collision enter. It's the one that we're going to want to use. And on collision enter is going to set our is grounded to true. And by hitting the jump button, it will set our is grounded to false. So why don't you guys spend 5 minutes doing that, and then we'll go through it together, make sure that everybody understands how that's working. And in the meantime, I'll do some other things that we can go over.
Is it possible to round the plane like a ball?
A plane is almost, I'm pretty sure, has to be rectangular. If you wanted to make it more like a ball, I would recommend a cylinder. And then you can, yeah, if we want to get rid of our quad, we can get rid of our quad and make our cylinder radius enormous. No, that's the capsule collider. I want these. I want the X and Y. No, X and Z. So yeah, this is how you would make a very large circular sphere like that. Let's drop it down. Does that make sense, how I did that? That's what you're going for, right?
Well, like a bowl with edges on the sides?
Ooh, like a bowl, like a hemisphere, you mean? Like a cereal bowl or like a cat bowl?
Yeah, as long as it has like a ridge.
That's a more complicated shape. I don't know. You could probably easily make one in a 3D modeling tool. And there are free Unity packages that allow you to extrude surfaces and things. Unity 3D editor. The best one is what's it called? Drawing a blank on the name. I thought it would pop up and I would just recognize it. Maybe it's called Mesh Builder, something like that. It's been a Pro Builder. Pro Builder is the tool or plugin that a lot of people use. It's created for Unity by Unity, and it can be used to make shapes like this. You can extrude and inset. That was the word I was looking for, inset. You've got grids and things. And from what I recall, unless they changed it, Pro Builder was free before. Set store. Really? Where did they get rid of it? Wow, that would be.
It wouldn't be the package manager.
That's a good place to try checking, yeah. Maybe they just moved it over to the package manager.
I see it
Let's
there.
try. Oh, did you find it in there?
Yeah.
Yeah. Okay, yeah. It's built by Unity. They took it out of their own asset store. I don't know why they would make it so difficult to find. But yeah, it is in the package manager. Good suggestion. That's the one right there. And it's pretty intuitive from what I remember, and it looks like they update it pretty frequently. There's a lot of Unity editor code, so that it even creates kind of like its own inspector where you can use icons and widgets and buttons to make your life easier and create surfaces and shapes and things without having to go and use an alternative third-party 3D modeling tool like Blender or 3D Studio Max. So yeah, Pro Builder. It's a good one. We won't go into, yeah, I don't think the focus of this class is the modeling part, but yeah, I would highly recommend playing around with that if you want to do your own models and shapes and stuff. Otherwise, the Unity store is just loaded with a lot of free assets. Apparently not Pro Builder anymore, but that is insane. I cannot believe they pulled it from their own store. Yeah, because these all cost, and Pro Builder's free. Yeah, look at all these cool sci-fi industrial assets that are completely free. Everything in this scene, if you want pipes or stairs or yeah, there's a lot of cool free assets out there. How are we doing on the double jump or eliminating double jump? Oh my goodness, where'd my cube go? Well, we fell. Something in my script. I know what I did. I think I changed the collider. Yep, this is what happens. My capsule collider, I altered the radius, and so it doesn't match the mesh renderer. And that's tricky. If you drop down any collider, I don't know if people are working or following along, but yeah, your collider and your mesh renderer don't necessarily have the same values. So even though my object looks like this flat pancake, the collider that's on it looks like this green box here. So we want to fix that and make it more appropriate so that my box doesn't go crazy when I hit play. That's what was happening before. Nope. That strange. Don't know why it's being fussy in the Y direction. That really kind of perplexes me. Works in the Z and the X direction, but does not want to work in the Y direction. At any rate, we're going to go back to our quad. So that one had a collider that was just fine. Even though it's a mesh collider, it's just a quad. All right, so let's go to our jump script. One thing I did while you guys were working on is that I made this jump height into a property. So now whenever we go over to the inspector, we can actually set the jump height using a handle. You know, it kind of passes the responsibility of tweaking these properties over to the person who's actually setting the values in the inspector in the game rather than having the responsibility fall on the programmer. Recall that if you set it equal to something, that doesn't mean that's what it's equal to in the script. That means that's what the default value is in the inspector. So this might say 250, but it's really dependent on whatever this value is in the inspector, so 300. So now whenever my code actually comes in and hits jump height in the update function, it will be 300 and not 250. Remember that, because that's not the way it is usually in C#. Usually whatever value it is up here, that's what your default value is, but the default value comes from the inspector, and then the inspector can get it from this if you're dropping the component onto a new game object. But we also want our private bool and call it is on surface or on the ground, and this will default to false because when we hit play and start the scene, we're actually just above the surface. And then on collision, we're going to set this is on the surface variable to true. And then we just want to make sure that whenever we hit the space bar, we also want to double check and make sure that it is on the surface. And then when we do hit the space bar, we know that we are no longer on the surface, and we can set is on surface to false. I know I went through that kind of quickly. I want to make sure that people understand what I just did. I added, this new function on collision enter that sets it to true whenever, we hit the surface. We've got the variable itself, and then we've got the conditional, and then the swap of conditionals when we actually hit the jump button. Is that making sense? So let's go ahead and go back over to our Unity editor and test. Because this new is on surface property is private, we will not see it in the inspector. If we were to change this to public and come back over and let Unity actualize, there it is on surface is in our inspector, and its default value is false. So let's go ahead and hit play and try our double jump. Jump, 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 jump. Nope, I'm only able to jump once. If we wanted additional debug information, so we want something to write out to the console, we could say debug.log and say you hit the surface. We could do that as well. I encourage you to use debug codes. They're useful. So we should see it almost immediately because we are falling when the scene starts, and then we hit the surface. If we hit it again and again, every time that on collision enter triggers, it's doing everything in this function here. Is that making sense to everybody? All right, good. Let's see here. What haven't we covered in our list here? We just covered scenes, we covered scripts, we covered vector 3s. Maybe let's create some new lights. Let's oops. Yeah, we haven't done a whole lot with lighting. Let's go ahead and add a script to our directional light so that whenever we hit the L button, the L key, it changes the color of the light. Does that sound like a good practice example for you guys? Let's spend 5 or 10 minutes creating a new script. So yeah, you can go to your directional light. You can scroll down and do add component, and you can do change light color, and this will create the new script. It will add it to your game object, and it will also add it to your project. Yeah, there's a variety of ways to be able to do that, but I would yeah, suggest maybe creating an enumeration of different colors. Yeah, I'll give you guys a couple of minutes. Is there any questions? Everyone's got kind of an idea of how to do that. Adam, were you able to fix your problem with not being able to set the property to private? Perhaps you were missing a semicolon or something. You will add the script to the sun, the directional light game object. Okay. Yeah, I'll give you guys a few minutes. All right, how's everybody doing with the color swapper? Let's go ahead and come over to our update function. It's going to be very similar to our jump function, except for we're going to be getting a different key, and we're going to be altering a different component. So the first line of code, and hopefully everybody was able to get this one, was if input dot get key down key code L. So if we are pressing the L key, does everyone get that one? So if we're pressing the L key, then we're going to want to get the light component that is on the same game object as our change light. So we're going to get light. And we can change the color property, and we can set it equal to something like color.red. So if we come over here and we hit play and we push L, it changes everything to red because our light is red now. If we wanted more colors, we would have to set up some kind of enumeration or some kind of if statement. So let's go ahead and put in some additional logic here. We can store these components and properties in temporary variables. So say we want to keep track of the color. Current color is equal to this. Just copy and pasted where we are saving the current color, in a property here, and then we can use current color and then if conditional. So if current color is equal to blue, then we can set it to red. Remember, conditionals are equals and not just a single equals. Else, if the color is red, then we can switch it to black, and if it's black, we can set it equal to green, and if it's green, then we can set it back to blue. And this will allow us to kind of flip through a number of different colors just by hitting the L button. Oh, what did I do wrong here? In this particular case, our default color is kind of some weird beige color, whatever this color is. And so none of these conditionals actually get hit.
The last if statement.
Yeah, if we got rid of this if, very good, or just an else, actually, else. Set it to blue. Yeah, that'll fix it. Good suggestion. Now we should be able to jump and change our colors with the L button. Oh. Is this making sense to everyone? I know not everybody had a computer science background, but Yeah, is everyone able to follow along in the logic and everything to get this colors changing? Um, all right, let's go to prefabs again. I feel like prefabs are worth going over again. They're very, very useful. They're kind of unique to Unity, I guess, or I had never come across the concept of prefabs until I encountered Unity. So let's create a script that whenever we hit the C button, it generates a new cube. And the cube will have the jump functionality, just like our existing cube. But we want to be able to create lots and lots of cubes just by hitting the C button if we want. So why don't you guys, I'll give you guys another 5 minutes or so to kind of try and do that on your own. What you're going to want to do is you're going to want to turn this cube into a prefab. In order to do that, you take the cube and you bring it over into your project and you drop it. And now it's blue. In your hierarchy, it also turned blue, so that if you want to go back and change that cube, you can do select, and you can open up the prefab, and now anything you do to this cube will change every cube in your hierarchy. So say that we have, can use the Control D to duplicate our cube. Let's move this one over here a little bit, right there. Notice how they're both that size. If I come over to my prefab, I just clicked right here. I selected my prefab and I open up that prefab and say I take its scale and I change it and I make it a little bit longer like that. And I come back to my scene now. Both of those cubes are now longer. Whatever, prefab they are, if you change that prefab over here, it'll change all of your prefabs in your scene. Except for the one thing it doesn't change is the position. The position of the prefab doesn't get updated. I think they did that because a lot of times people don't want their positions being changed. They just want certain properties to change. And so, yeah, that's how you drop prefabs, but you can also instantiate these prefabs. So go ahead and create a new script. You can put it on your camera, you can put it on your light, you can put it on really anything except for the cube itself, and call it cube generator. And this cube generator will instantiate new cubes whenever you hit the C button. Yeah, go ahead and give that a shot. I'm gonna, yeah, stop. Well, yeah, I'll continue to share my screen, but go ahead and do it on your screen and don't watch me do it. Everybody getting there? I'm just kind of playing around, adding some additional move functionality to my cubes. All right. So did everyone able to get their cube generator to work? Adam, got your cube generator working? Taylor? Chris? Yeah, I want to make sure that everybody was able to get their generator working. All right, good. Taylor, got yours working? Not yet.
Fine.
Okay. Chris, did you get the script on there? Are you getting a null reference, or what's happening when you try and generate your cubes? You can also share your screen too if you want. We can. It's possible maybe when you created your script, you made it. What happens is, you want to make it a property here, and you want to drop your prefab. Make sure that it's set in the inspector. Yep, Adam, that's exactly how you do it. So, yeah, inside of your cube generator, you can actually instantiate primitives as well. That's what I did because our cubes have cool functionality. But if I wanted, instead of dropping our prefab on here, another way of instantiating this would be to do, if you hit C, then you can instantiate, I think it's called primitive type.cube. We could instantiate our cube that way. Oop. Instantiate likes a game object usually. And it's complaining because our cube is just an enumeration. I thought we could do primitive type. One second, let me double check on this. It's called create primitive, not instantiate primitive. There they are. Yeah, instantiate only takes prefabs. If you want to instantiate a primitive, they have a special function here called create primitive. And so if I want to be able to do things to this primitive, we want to keep a reference of it. So game object and call it our new cube. And then we can actually do our new cube dot add component. And this is where we would add our jump component. It's called jump. Why is that not? Jump is something else. No, it's. Maybe that's not the syntax. I think it's actually That's the syntax. This will add the jump component to our cube, our newly created primitive cube. It won't have the new script that I just added to it that I was kind of doing for fun. But now when we hit play, we hit C, ooh, it generated the primitive at 0, 0, 0, which is not really where we want it to be. So instead, we can take our new cube's transform, and we can translate it up just a tiny bit. Everyone understand what I did? I did it kind of fast. We're taking our new game object, which we just created, this new primitive. We want to get the transform because the transform's what's got the position and the rotation and the scale. What we're doing is we're changing the position and we're moving it up by 2 units. And that way we're not instantiating our new cube right in the middle of our plane because, yeah, it's not where we want to have it. Oh, look at our cube is floating. Anyone know why our cube is floating? Our cube is floating because it doesn't have gravity. And why doesn't it have gravity? Because, very good, Adam. It doesn't have a rigid body. So if we want to add a rigid body to our cube, our primitive cubes, we can come over here. We can do our new cube dot add component. We're adding a rigid body, and now we will be able to have gravity, and our jump functionality will work as well. Jump wouldn't have worked without gravity. So yeah, that's our new primitive cube generator. What I did is, here we can comment this out. I made a new function, or not a new function, a new class called moveCube. It's not too complicated. What happens is it's a lot like the jump, except for rather than going and adding a vector 3.up, we have left, back, right, and forward for the different arrow keys. And then I took that move cube script file and I dropped it onto our prefab here. So our prefab now, which is a game object, always has a transform. It's got the mesh renderer and the mesh itself. It's got a collider. It's got a rigid body so that it has gravity and can detect that it's colliding with the surface. It's got the jump script that we created originally, and now it also has this move script, which I just created. And inside of my main camera, I have cube generators, which are generating these cubes. So every time I push C, it's going to generate a cube. Notice that if you generate a cube on top of each other, they both have rigid bodies and colliders, and so they're going to pop all over the place because your colliders are colliding with each other. And at the same time, we have this cool move function, so we can create lots of blocks and make them move all over the place. Notice over here in our hierarchy, there's a lot of cubes that are created. We probably want them to die after they go below a certain Z position, or a Y position, because if we click on one of these guys and we look at it in the scene, they're all falling off the screen. Their transforms are in the negative 4,000 Y. So let's go ahead and add a function that destroys those cubes once they've dropped below negative 100y. Go ahead and give you guys a couple of minutes to do that. You're going to want to put that check in the update function of either your jump or most likely your jump. You guys don't have the move cube script that I wrote. Maybe you wrote it already, but yeah, everyone should have the jump. Go ahead and put it in the update function of your jump so that if your Y position is below negative 100, then destroy yourself. And this is covering the destroy function of our game object. So we've covered today, again, instantiation and destroying. Let's cover parenting and children again after this. But yeah, go ahead and write that destroy function because you're going to have things. This happens very often actually in side scrollers and different games where you're generating something every few seconds, but then after 10 seconds, you're never going to see that bullet or that asteroid or whatever it is that you were shooting at the player ever again. And so you want it to destroy itself either when it passes a certain position threshold or a timing threshold. You can set timers using coroutine, and after 10 seconds, destroy yourself. How can we create a prefab again? You take it from your hierarchy and you drag it into your project. So normally if you want to drop a prefab into your scene, you take it from the project and drop it into your hierarchy. But if you want to create a prefab, then it goes the other way, where you take your game object and you bring it over to your project. And if you try and drop one that's already there, I think it asks you, if you want to override it or if you want to create a different variant, because it knows, hey, you already have this prefab over in your project. You're basically duplicating. Are you sure you want to do that? And then once you have a prefab created, you can go ahead and remove those things from your scene. And drop them over there anytime you want. And any properties you have set, notice that when I created this prefab, my cylinder was actually turned off. Therefore, the prefab itself is turned off by default. It's very consistent. Whatever you do to your game object before you make it a prefab, that's what the prefab turns into. All right, let's hopefully everybody was able to get the destroy code working. I deleted all of my cubes, so if I wanted to open up the jump script, the fastest way is probably just to double click on it in the project window. And so now an update. If, and this is probably the only tricky part, we want to get the cube's transform.y, transform.position, .y is less than negative 100. Then let's destroy ourself, and we are a game object. Destroy ourself. If we did destroy this, it wouldn't quite work. It would destroy the jump component on our cube, but not actually the cube itself. if you want the cube itself, you do game object. And this is kind of nice. You can get, your game object from any component that's on any script that's on the game object itself. And so now let's go ahead and come over and test and make sure that our blocks are dying. See. Jump them all off. And wait for it. There they go. They all died. All the cubes got collected by garbage collector. All of that memory came back, which is good because otherwise, yeah, you can make a lot of cubes really, really fast. I'm using key down, but if I wanted rapid fire on my cube generator, I just change this from get key down to get key, and we can generate cubes pretty quickly, basically every frame. Just spewing cubes all over the place. And they move too! Yeah, that filled up our hierarchy pretty quick. And so they died just as quick. For some reason, it isn't working. What's not working, Adam? Here, I'll pull up my Visual Studio and go to my jump. Destroying the cubes. Do you have it in update? And make sure your cubes have the jump component on them. You can even share your screen too. We can have a look together. Maybe there's something else is off. That's kind of, there's a lot of things that can go wrong in Unity as well. Especially when your game starts to get really complex. You're looking and you think it's one problem when it's, something completely different, where you forgot to add a rigid body, or you forgot to turn on trigger to true, or something like that.
All right. We'll share screen.
Here, I'll stop presenting real quick.
Oh yes, this is what I have.
Let me pause. Pin to screen. How do I make it bigger here? Have transform. How do I make this bigger? My resolution is not.
I mean, I can try to increase the size.
Yeah, if you use control and your mouse wheel, it'll zoom in. It's just kind of small. Let's see.
Is that better?
Yeah. What's happening is you have your check inside of the if that's checking space. See how your conditional is inside of another conditional? They're nested.
Oh, it's inside the if statement.
Yep. Just go ahead and cut that out and put it after the bracket.
All right. Yeah. Thanks.
Yep. If you hit save, then yeah, it should work. And actually, it would even destroy them, right? If you had hit spacebar and they were below that Y threshold, they would still get destroyed because you would have hit both of the conditionals.
Yeah, it works now.
Yep, very good. All right. Okay. Got about 10-20 minutes left. I was gonna try and do another example of parenting and unparenting. Trying to think how we might do that with this example here. Let's see here. Let's create, make sure you're turned off here. Let's go ahead and create another primitive. Let's create a cylinder. This is going to be our parent. Make sure that the cylinder is up above the surface. And yeah, let's give it a rigid body so that it can jump. And let's even add the jump script to it. So here's our rigid body, simple enough. Here's our jump script, simple enough. And now if we hit play, our cylinder should jump just like our cubes did. But now let's go ahead and add one or two more cubes. Move them to appropriate positions, like so. And then we want to parent these cubes to the cylinder. In order to parent it, you just kind of drag and drop it there. And that will allow you to parent the cubes to the cylinder. And now you'll notice that whenever you jump, the children jump with it. Let's write a script now that unparents those cubes from the cylinder so that they become their own top level cubes, right? We want something so that, you know, this cube will unparent itself from the cylinder, something like that. And so that that cube now no longer is parented to that cylinder. So yeah, this script will go on the cylinder and call it unparent. And yeah, take a shot, take 5 minutes at writing a script. Trigger it with the U key so that whenever you hit U, you loop through all of the game objects that are your children, and you unparent them. Yeah. Use the teletext. I don't even remember exactly what the exact function names are, but go ahead and give it a shot at writing a new script called unparent children. Or if you can't get it to unparent, you could even loop through and destroy all children. That's kind of a mean script name, destroy all children, but yeah, this is what they're called in Unity. They're called parents and they're called children, and this is how they show up in the hierarchy. So go ahead and write your function to unparent the children from the the cubes from the cylinder. Yeah. All right, how's everybody doing? I'm actually getting a little bit of kickback as well. I thought we could just cycle through all of the transforms. But yeah, hopefully, anyone else, did anyone get it yet? Inside of our unparent children script, we've got our U button detector here. And then what we want to do is normally cycle through all of the transforms that are in our game object. And then we take those transforms and we switch their parent to our current transformed parent, so the cylinder's parents. Let's give it one more go here. Ah, I know what I did wrong. There are two functions that are named almost identical. There's get component in children, which gets the very first one, or there's get components plural in children, and that is the one that you want. So now I think I solved it here. Yep. All right, so not sure if anyone was able to get that, but come back and look at my screen real quick and I'll go through it. Now we've got our cylinder here. It's got the two cubes that are children. You can see that they're children because they're indented slightly. These cubes actually could have children as well. So if I wanted to create another cube child like this, we could bring it up here and then reparent it to this cube here. So now we've got kind of a family chain here where this is the grandfather, grandmother of this particular cube. If we hit play now, I think our cube's gonna get tipped over here. But if I hit U, it'll trigger my one function and the cube itself falls over. None of these, or the cylinder itself falls over. None of the cubes did because they don't actually have rigid bodies on them. But let's go back over to the script. First line is pretty intuitive, but the second line, this is kind of the magic where we're looking at our current game object, and in this case, our current game object is the cylinder because unparent children is a component of the cylinder. So that cylinder, it's going to go through all of the children of that game object, and it is recursive, and it's going to look for this component. And since every single game object has a transform, we're basically talking about every single child that's in our cylinder. And what we're doing is we're taking that child, we've got a temporary, reference to that child, and we're taking that parent, and what we're doing is we're changing its parent to a different transform. We're repairing it to the parent of this current transform, this cylinder transform. So whatever my cylinder's parent is, that becomes the new parent of my child. And so when I come back over here and I restart here, and I look at my cylinder, whenever I hit the U button, all three of these cubes are going to reparent to the parent of cylinder, which is our scene. And so when I hit U, look at all of the cubes, they fell off. They're their own parent now, and cylinder's kind of rolling around on the ground because it's got a rigid body, but it's a capsule collider, and capsule colliders actually aren't cylinders. And so that's why it's kind of rolling around like that. If you were to extend the capsule collider and look at it in the scene, it would maybe make a little more sense as to why that cylinder is rolling in that way. It's because it's got, you can't see it very well, there's a green line here. It's a capsule collider when it should have probably been a cylinder collider. So now it just kind of looks silly. But do people have questions on parenting and unparenting? We can do another quick example where, yeah, let's turn all of the cubes that are our children, let's turn them blue. Does that sound like a good final test to see if we understand our parenting and unparenting functions? Really, the most important thing, the most important takeaway is probably this get components in children function, where you're looping through and getting all of the components in your children. So I'll give you guys a few minutes to try and do that. I'll do it on my own here. Go ahead and, yeah, change it. You can either create a new script. I'm just going to change my unparent children script so that whenever I push U at unparents, or whenever I push C, it changes the color of all of my children. Oh, fair. Huh. All right, so guys might not quite have gotten done yet, but yeah, I'll show you the secret trick here. So it's very similar to the last function we wrote where we push U and we unparent everything, but instead we have C, which I realized quickly that we already have a C code. The C code was used to generate cubes, but yeah, you can generate cubes and change colors at the same time. So what happens is we are going to look through our cylinder, and we're going to look at all of the children. And if those children have a mesh renderer, we're going to grab that mesh renderer component. And each mesh renderer component has a material which has a color, and we can set that color equal to blue. And so now when I come back over here to my scene and I hit play, when I hit C, it generates some cubes, and it also changes my everything to blue. Oh, that's interesting. It turned my cylinder to blue as well. I'm going to say that get components in children also gets the components that's on the current game object as well. If I wanted to not turn these cubes blue, I could use the U key first to unparent them. See, now they are no longer children of our cylinder. And if I hit C, only the cylinder turns blue, and we also get lots of cubes. Blah! All right. Do you guys have any other questions for now?
What about
Go ahead.
make sure we can't create more than our max amount of cubes?
You mean there's not really a max number of game objects that can exist in your scene. Your computer will slow down, but I've seen thousands, tens of thousands of game objects in a scene before. Really depends on how fast the computer is and how big the or how complex the mesh renderers are of the objects. These cubes, yeah, I feel like you could probably have a million of them in the scene at once. It's more like, because they don't have very many vertices, right? It's more like if you have some player model that's got, 50,000 polygons. If you've got 10 of those in a scene, your scene is going to slow down for sure, right? It really depends on how complex your models are. And a lot of the models that you end up dropping into these scenes, they will have lots of children, because the way that bones and things work for physics and such, a lot of your models will end up having a root, a parent, which is either the head or the body, but then the arms are children, and then the feet are children, and the legs are, everything's a child of logically what you would think the parent would be. And then you can use that for physics, and you can use that for collisions. And a lot of times more complex models will have lots of children. And it makes sense, because if you're rotating your body, you're also rotating your arm, and you're rotating the feet, and everything rotates with the body. And so, that's kind of the way Unity does it, and it's relatively intuitive. Any other questions? Are you guys wanting me to look for homework for you to do? Are you finding enough things on the Unity Learning portal to kind of fulfill what you want to do? I mean, we've only got 2 days until the next class anyhow, but I was just wondering if you guys want me to look online and find some examples for you to do, or if you're just fine kind of finding stuff in your own. I'm also curious if we're going too quickly. You know, we kind of step back, and it feels like everybody was able to kind of follow along today. I hope. All right, well, I'll be available if you guys have any questions. Just message me on Slack. I'll try and get this video posted in the next hour, so it doesn't immediately drop into the Google Drive. But yeah, it takes probably about 20 minutes to process, and then I can grab it and throw it on the Slack channel. Yeah, if there's anything you guys want to cover, I know a lot of people in the beginning said they wanted to cover VR stuff. If that's still the case, you know, we do definitely want to make sure that everybody knows all of this stuff, or at least what it is. Yeah, maybe we'll go back and do a little more Canvas stuff. We haven't done actually much with the UI Canvas, and there's really if you can design a really nice looking GUI, that's a powerful skill to have as well. Because you can do HTML5 builds. I mean, you can build websites with Unity and the Canvas if you wanted to. So, all right. Well, if we don't have anything else, yeah, I will see everybody on Thursday. Thanks.